Somewhere in the Australian outback, a single train stretches 7.3 kilometers across the desert, longer than 70 city blocks, hauling nearly 100,000 tons of iron ore, controlled by one person. In the Sahara, a freight train has been running through the desert every single day since 1963, carrying loads so massive it shakes the ground miles before it arrives. In South Africa, a train regularly hauls 41,000 tons across mountains, using electricity at twice the standard voltage. These are not machines, these are moving cities. Here are the 10 most powerful cargo trains ever built. Number 1. BHP Iron Ore Train. On June 21, 2001, an Australian mining company called BHP Billiton did something that had never been done before in the history of rail transport. They assembled a single freight train that stretched 7.352 kilometers, just over 4.5 miles, across the iron ore country of Western Australia's Pilbara region and sent it rolling 275 kilometers from the Yandi mine to the port of Port Hedland. The train consisted of 682 wagons and was powered by 8 General Electric AC6000 CW diesel-electric locomotives, each producing 6,000 horsepower. Combined, those 8 locomotives generated 48,000 horsepower, roughly equivalent to the combined output of 240 standard passenger cars. The total weight of the train reached 99,734 metric tons, carrying 82,000 metric tons of iron ore cargo. The entire operation was controlled by a single driver. To keep coupling loads manageable along that extraordinary length, the 8 locomotives were not all placed at the front. They were distributed at intervals along the train, each communicating electronically with the lead cab through a distributed power system. The driver in the lead locomotive effectively controlled all 8 engines simultaneously from one seat. That run earned the Guinness World Record for the heaviest and longest freight train ever assembled, a record that still stands as of today. The 8 AC6000 CW locomotives used to set the record remain the most powerful diesel locomotives ever to operate on Australian soil. What makes this record particularly remarkable is the context. The Pilbara iron ore railways are not exhibition tracks. They operate continuously, around the clock, moving tens of millions of tons of raw material every year. The 2001 record run was not a stunt. It was a demonstration of what the system was capable of at its absolute upper limit. Number 2. The Sishen Saldanha Ore Train. South Africa's Sishen Saldanha Railway Line, also called the Oryx Line, is one of the most impressive heavy-haul railways on Earth. It stretches 861 kilometers from iron ore mines near Sishen in the Northern Cape to the port at Saldanha Bay on the Atlantic coast, and it was purpose-built for one job, moving as much iron ore as physically possible. What makes the Oryx Line technically extraordinary is its electrification system. While most electrified railways around the world run at 25 kilovolts AC, the Sishen Saldanha line was built at 50 kilovolts AC, double the standard. This was a deliberate engineering decision made during construction in the 1970s to allow heavier loads and longer distances between power substations along this remote and demanding route. Trains on the Oryx line regularly consist of 342 wagons, each carrying 100 metric tons of iron ore. The trains are at least 3.78 kilometers long, making them the longest production trains, meaning trains that run regularly in scheduled freight service in the world. Total train mass reaches 41,400 metric tons per journey, and the line carries approximately 60 million metric tons of iron ore every year. Modern operations use a mix of Class 15E electric locomotives and diesel-electric backup units. The Class 15E was introduced in 2010 and uses Toshiba-made 3-phase AC motors controlled through IGBT technology. 5 of these locomotives, distributed along the length of each train using radio-controlled distributed power systems, manage a single 342 wagon consist. The distributed power arrangement is essential. Placing all the locomotives at the front of a 3.78-kilometer train would create coupling forces that would tear the wagons apart. In 1989, before modern distributed power existed, The Orex line set its own single-run record, a consist of 660 wagons, 7.3 kilometers long, weighing 71,765 metric tons, hauled by 9 electric and 7 diesel locomotives. That run held the world record for the heaviest train until the BHP record of 2001. Number 3. The Mauritanian Iron Ore Train. Most people have never heard of the Mauritanian Iron Ore Train. That is a failure of attention, because this train is one of the most extraordinary freight operations on Earth, and it has been running continuously since 1963. The train connects the iron ore mining town of Zouérat, deep in the Sahara Desert, to the port of Nouadhibou on the Atlantic coast. The total distance is 704 kilometers, traveled on a single-track line that crosses some of the most inhospitable terrain on the planet. Daytime temperatures along the route regularly exceed 40 degrees Celsius. At night, temperatures approach freezing. There are no roads for much of the route. There is almost nothing out there except sand, rock, and the train. Each consist runs up to 210 wagons, with every wagon carrying up to 84 metric tons of iron ore. Train length reaches between 2.5 and 3 kilometers depending on loading. Total payload per trip reaches approximately 17,000 metric tons of ore, and the railway moves around 16.6 million metric tons per year in total. The trains are operated by the state mining agency SINIM, Société Nationale Industrielle et Minière, which has controlled the line since it was nationalized in 1974. The locomotives are diesel-electric units from Electromotive Diesel, typically running 2 to 4 per consist. They have hauled their loads across sand, rock, and extreme heat every single day for over 6 decades, without the kind of infrastructure support most heavy-haul railways take for granted. What makes the Mauritanian train uniquely remarkable, beyond its raw power and scale, is its cultural dimension. For decades, passengers, locals traveling between desert communities and the coast, have simply climbed atop the iron ore wagons and ridden for free. Adventure travelers from around the world have made the journey, sitting on top of iron ore dust under the Saharan stars, riding one of the most extreme freight trains in existence. Number 4. The Fortescue Metals Group Train. Australia's Pilbara region is home to some of the richest iron ore deposits on Earth, and the freight railways built to extract those deposits are among the most powerful on the planet. Fortescue Metals Group, which began construction of its railway in 2007, built one of the most technologically advanced heavy-haul rail systems ever constructed from scratch. Fortescue's network spans over 760 kilometers of dedicated heavy-haul track, purpose-built to Fortescue's own specifications. Their ore trains regularly carry more than 32,000 metric tons of iron ore per journey, with 240 wagons per consist. The rail line was originally designed for 40 metric ton axle loads, already among the heaviest in the world, and has since been upgraded to handle 43.5 metric tons per axle, with technology being developed to handle 45 metric tons per axle on portions of the network. Fortescue became one of the first railways in the world to implement fully autonomous train operations at industrial scale. Their AutoHaul system, the world's first fully autonomous heavy-haul long-distance rail operation, was brought into full service in 2019. Under AutoHaul, trains move autonomously from the mines to the port without drivers aboard the locomotives, controlled remotely by operators in a Perth operations center. The system manages the trains, handles speed adjustments for grades and curves, and even docks the trains at loading and unloading facilities. Each autonomous train is over 2.8 kilometers long. The technology represented one of the largest industrial automation projects in history. Number 5. The Union Pacific Big Boy. The Union Pacific Big Boy is the most powerful steam locomotive ever built for revenue freight service. 25 were built between 1941 and 1944 by the American Locomotive Company, designed specifically to haul heavy freight over the Wasatch Mountains of Utah without requiring helper locomotives. The Big Boy stretched 132 feet in length and weighed approximately 540 metric tons when fully loaded with water and coal. It produced around 6,200 horsepower at its drawbar. The effective pulling power delivered to the train behind it. That figure made it capable of hauling a 3,600-ton freight train over the Utah and Wyoming mountains at sustained speeds of around 40 miles per hour. a feat no earlier locomotive could match on that route without assist. The engineering that made the big boy work was its articulated design. The locomotive was built in two sections that could flex independently around curves, allowing a machine of extraordinary length and weight to navigate mountain passes and sharp curves that would have been physically impossible for a rigid frame locomotive of comparable size. The two sections shared a single boiler but rode on separate sets of driving wheels, each section essentially functioning as an independent locomotive. All 25 big boys were retired from revenue service by 1959 as diesel-electric locomotives took over American railroads. 8 have been preserved. One of them, Big Boy number 4014, was restored to full operating condition by Union Pacific and returned to steam in 2019, becoming the largest operational steam locomotive on Earth. It still makes occasional excursion runs today, operating along portions of the original Transcontinental Railroad route. Number 6. Vales-Carajás Railway. The Estrada de Ferro Carajás. The Carajás Railway connects the Carajás iron ore mine in the state of Pará with the port of São Luís in Maranhão, Brazil. It is 892 kilometers long, making it one of the longest dedicated iron ore railways in the world. The line is operated by Vale, one of the largest mining companies on Earth, and it moves some of the richest iron ore deposits ever discovered. The Carajás mine contains one of the largest iron ore reserves on the planet, with ore grades reaching up to 67% iron content, extremely high by global standards. The railway was built in the 1980s to connect those reserves to export markets, and it has been running continuously ever since. Trains on the Carajás Railway typically consist of 330 wagons, each carrying 100 metric tons of ore, for a total train weight exceeding 40,000 metric tons. The trains stretch approximately 3.4 kilometers in length. Vale regularly moves around 130 million metric tons of iron ore along this route per year, making it one of the highest volume freight railways in the Americas. The locomotives used on the Carajás system are General Electric models, primarily GE ES43 BBI units, a modified version of the Evolution series built specifically for Brazilian conditions. Multiple locomotives work in distributed power arrangements along the length of each consist. The railway also passes through portions of the Amazon basin, meaning the locomotives and track must perform in extreme heat and humidity while maintaining their enormous haulage capacity. Number 7. The Norfolk and Western Coal Train. The Norfolk and Western Railway, which later became Norfolk Southern, built its entire identity around moving coal. The railroad connected the coal fields of West Virginia and Virginia with industrial ports and power plants across the eastern United States, and it engineered itself from the tracks up to handle the heaviest possible loads. In November 1967, the Norfolk and Western set an American rail record that would stand for years. A loaded coal train made the journey from Iga, West Virginia, to Portsmouth, Ohio, hauling extraordinary tonnage on a route through mountain terrain that most railways would have found punishing. The consist used EMD SD45 six-axle diesel-electric locomotives, which were among the most powerful diesel units available at the time. What made the Norfolk and Western coal operation remarkable was not just the individual record run, but the sustained daily output. The railroad was built to a standard that allowed heavier axle loads than almost any other line in North America, enabling it to move more coal per car and per train than competing routes. Its engineering standards, the quality of its track, bridges, and grade construction were among the highest of any American freight railroad. Norfolk Southern, the successor railroad, continues to operate heavy coal trains on much of the original infrastructure today, moving millions of tons of coal and other commodities through the Appalachian Mountains on trackwork that in many places traces directly back to Norfolk and Western's original construction. Number 8. The Soviet Union's Kazakmys test train. In 1986, the Soviet Union ran a freight train that no country has matched in one specific category: sustained heavy haul performance in extreme cold. A train transporting coal from what is now Kazakhstan to the Ural mountain region reached a recorded total weight of 43,400 metric tons, 439 wagons pulled by multiple diesel locomotives across the vast distances of the Soviet rail network. This was officially a test train, designed to demonstrate the feasibility of running such enormous loads consistently across the Soviet network, rather than a scheduled revenue service. The Soviet railway system, which operated as a single integrated national network, needed to know what its infrastructure could endure, and this run answered the question definitively. What made the Soviet achievement particularly impressive was the operating environment. Temperatures across the Kazakh steppe regularly dropped to -40 and -50 degrees Celsius in winter. Diesel engines lose efficiency in extreme cold. Rail steel behaves differently, becoming more brittle at sub-zero temperatures. Lubricants freeze. The infrastructure has to be engineered to a completely different standard than railways operating in temperate climates. The Russian railways that inherited the Soviet network continued to develop heavy-haul operations in these conditions. The Sonara GTH-1 gas turbine electric locomotive, developed for Russian railways, produces 11,285 horsepower and is designed to haul 9,000-ton cargo trains on non-electrified sections of the main line, including portions that see the most extreme winter temperatures. Number 9. China's Shuhuang Railway. China is the world's largest producer and consumer of coal, and to move that coal from the mining regions of the northwest to the power-hungry cities and ports of the east, it built one of the most powerful heavy-haul rail corridors in human history, the Shuhuang Railway. The Shuhuang Line stretches 586 kilometers, connecting the Shenhua Group's coal mines in Shandong, one of the largest coal-producing regions on Earth, with the port of Huanghua on the Bohai Sea in Hebei Province. It is a dedicated freight line, built to handle nothing but coal, and it was engineered from the start for the highest possible capacity. Trains on the Shuhuang Line run with 250 wagons per consist, carrying approximately 20,000 metric tons of coal per train. The line moves hundreds of millions of tons of coal annually, making it one of the highest throughput coal railways in existence. The locomotives powering these trains include the Chinese-built HXD-1 and HXD-2 series electric locomotives. The China Railways HXD-2, for example, produces 13,410 horsepower per unit and generates a tractive force of 756 kilonewtons. Multiple units are run in combination to manage the full 250 wagon consists. The scale of the Shuhuang operation is genuinely difficult to comprehend. It runs 24 hours a day, every day of the year. The trains move at intervals of minutes rather than hours. The line handles enough coal per year to fuel entire nations. It is less a railway and more an industrial organ, a circulatory system through which energy flows from resource to consumer on a continental scale. Number 10. India's Vasuki. On March 1, 2024, Indian Railways made history by running the longest freight train ever operated on its network. The train was named Vasuki after the legendary serpent from Hindu mythology, and it stretched over 3.5 kilometers in length, combining 5 full rakes of wagons into a single moving unit. Vasuki was powered by 5 separate electric locomotives, distributed along its length, each unit managed through coordinated electronic control. The train carried mixed cargo, including coal, covering the route between Bhilai and Korba in the state of Chhattisgarh. A journey it completed in approximately 7 hours under the operation of a single driver and 1 assistant. The run was designed by Indian Railways as a demonstration of what its network could achieve with distributed power technology and careful route planning. India's rail network is one of the largest and most congested in the world. Nearly 14,000 trains move across it every day, and running longer, heavier trains means carrying more freight per slot on that congested network. Every additional ton moved per slot means fewer total trains needed, which reduces delays and increases throughput across the entire system. The Indian Railways WAG-12B electric locomotive, which powers many of India's heaviest freight trains, produces 12,000 horsepower per unit and is capable of hauling 6,000-ton freight trains in regular service. It is among the most powerful electric freight locomotives currently in production, and its deployment across India's freight network is steadily increasing the country's heavy haul capacity toward world-class levels. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.